Hello everyone and welcome to a new tutorial. Today we will recreate the Discus of Light visual effect from Elden Ring using Unity's shader graph. Keep in mind we will recreate its visuals and not mechanics. After you are done following this tutorial, you can alter its visuals to make it look however you want. Here are a few variations I have made for my Patreons. By the way, if this type of content interests you, please don't forget to like and subscribe. This is a very small channel, so every bit helps out a lot. Without any further ado, let's get into it. Create a new shader graph and name it Discus of Light. I'm going to full screen this so it is easier for you to follow. To preview the effect a bit better, I will change the preview window to a quad. Okay, so start by adding a Voronoi noise and multiply this with a new property of type colors, which we will create up here real quick. Set its mode to HDR and color to a light yellow. Drag it into our graph and connect it here and then the output of the multiply node to the base color. Okay, cool. We need to twist this noise for our effect, so add a twirl and connect it to the UV of our noise. And a rotate node to the UV of our twirl. If you change the value of the rotation, you can see our noise moves. To make it rotate over time, we add a time node connected to a multiply node, and then up here we create a new property of type float and call it rotation speed. Then connect it down here and plug the multiply into our rotation. Now if you change the property value, you can see it rotating over time. Let's do the alpha clipping real quick. Change the surface type to transparent and connect the Voronoi noise directly to the alpha. Alright, good stuff. We need to mask out the borders though. So add a sample texture 2D and select the default particle that comes with Unity to be the texture of this. And connect the RGBA to a power and 1- node. Also, the 1- node needs to be connected to a power. Create two new properties called inner edge and outer edge. Add a clamp node and connect them like this. And you will see we got a disk. This is exactly what we need. To give you more control over the disk, connect the outer edge up here, and if you change this property value, you will see the outer edge of this disk getting bigger and smaller. Same principle applies to the inner edge down here. We have to apply this disk mask to our noise though. We do this quite easily by simply multiplying them both and connecting this to the alpha. It's pretty hard to see at the moment, so create a new property called brightness. If you multiply the noise with the brightness property, it will look extremely bright. So instead we multiply it with the disk mask below and voila! Let's fade it out now. Create a new property called fade and multiply this property with our disk mask and plug it into the alpha. Now if you change the fade, it will, well, fade in or out. I want to add a bit more control over our noise, so let me just move stuff around a bit to make space. And create a new property called noise scale and plug it into the cell density of our Voronoi noise. I will do the same for the twirl strength. Alright. It's looking pretty cool by the exception of these pixels on the edges, right? To fix that, just increase the outer edge property and boom, they're gone. I'm gonna duplicate all of this so we can add even more detail to our noise. Connect these two like so, and actually we don't need this. We don't need this either. Add a tiling and offset node. Plug the rotate to its UV and connect the tiling to our Voronoi noise. Create a new property of type float called noise subtraction and plug it into our Voronoi noise. Add a subtract node and plug both of our Voronoi noises together in there. And you can see it now, it has like these black patches around it. You can of course change this to whatever you want. You can have no patches or a lot of tiny little patches, I don't know. It's up to you. I will leave it at 3 for now. Connect this to our disk mask and voila! Last thing we will do is we have to allow Unity's particle system to change the fade property. We do this by using the UV node. Set it to UV1 and split it so we can grab the R value of the UV to swap the fade property. You can delete the fade property now since we will control it through the particle system later. And that is it for the shader. Hit save and let's head back to our scene window. Create a new folder called textures and another called materials. Inside the textures folder, import these two textures, which are available for you to download in the description down below. Select them both and enable alpha its transparency, then click apply. Alright, now right click your shader and create a material named Discus of Light main material. Drag it into your material folder to keep things nice and neat. In your hierarchy, right click to create a new particle system and call it Discus of Light. Reset its rotation and position. Duration and lifetime to 1. Start speed to 0. Uncheck shape so that they all span on the center of this transform. Under render settings, assign our new material. If you move around, you will notice it is always looking at you. So set its render alignment to local and go up here to enable 3D start rotation. Set it to be a random between two constants, x-axis to a -90 and on the y-axis to 0 and 360. It's starting to look like it now. We need to make it fade in and out now. If you go to emission and change its rate, you can see it is not fading. So let's set its emission to 20, then down under render settings, check custom vertex streams and add a custom one that X, Y, Z and W. This is our connection to the UV node on shader graph. Close the render settings and right above it you will see the custom data. Enable that and expand it. On custom 1, set it to be a vector, and if you change the Z value you can make it fade in and out now. The cool thing about this is that you can set it to be a curve. What we want though is a custom curve, so pick the first one that is straight. Let me make this bigger. Right click the start key and select edit key, then assign its value to 0. Do the same for the last key. Go somewhere in the middle and double click to create a new key, then simply drag it up here to create this kind of like mountain. I have OCD when it comes to these long values, so I will set its time to 0.5 and value to 1. Now it's a perfect curve. Great, now if you go up here to emission and set its rate to 1, you will be able to see it fade in and out. So far so good. I think it's looking pretty great so far. For the material values, I will do inner edge to 2 to make the disc more thick, and outer edge to 0.5 is fine. Twirl strength to 10, noise subtraction to 1, rotation speed, I guess 1 is fine for now. Duplicate the particle system and rename it outer rings. Disable the Discus of Light for now so we can work on this particle system. Inside your materials folder, I'm going to duplicate the Discus of Light main and name it Discus of Light Outer. Assign this material to our new particle system and go back up here. Set its size to something a little bit bigger than the main Discus of Light. I will also increase its lifetime and duration to 2 seconds. Under emission, I will lower it to 10, and for its material settings, I will increase the rotation speed, lower the noise scale, and increase the inner edge. I will also make it much brighter. Let's enable other particle systems, and the outer rings seems to be a bit too big, so I will lower its size. And also make it a little bit less brighter too. Okay, that looks better. Duplicate the Discus of Light and rename it Trail, then select both the trail and outer rings, drag them inside the Discus of Light. Okay, I'm going to move away the trail to work on it on the side. Set its simulation space to world. Lifetime and duration to 2 seconds. And under emission, I will set its rate over time to 5. Now move it around and voila! We have the first part of our trail. Reset its position. Create a new particle system and call it Stars. Duration and lifetime to 2 seconds. Start speed to 0.1. Start size to random between 2 very low values. Simulation space to world. Increase its rate over time to 20. Change its shape to circle and rotation to 90 on the x-axis. Its radius is too big, so lower it to fit your discus. Set its radius thickness to 0.5 so we have a donut shape. Go down here and enable color over lifetime. Make them fade in and out. Inside your materials folder, create a new material with a particle shader. In this case, I will use the Universal Render Pipeline default onlit particle shader. Set its surface type to transparent and assign the start texture to the base map. Now simply drag this new material to the stars. Alright, pretty cool. I just gotta change its color to a bright yellow. Drag the stars particle system into our Discus of Light and move it around a bit. It's coming together nicely. Actually, for the stars, they are supposed to move more randomly, so set its start speed to 0 and go down and enable noise. Strength to 0.1 and frequency to 5. Okay, that looks much better. Duplicate the stars and rename it Bloom Trail. Duration and lifetime to 1 second. Start size to a constant of 0. Simulation space to local. Uncheck color over lifetime and noise. Then enable trails. Assign the trail material to be the default particle system that comes with Unity. Under trail settings, check world space, uncheck dial with particles, uncheck size affects width, and now if you move it around, you will see this massive bloom trail. Set its width over trail to 0.1 and move it around again. Okay, that is more like it, but there are too many. In Elden Ring they are quite random and appear not that often, so I will remove its rate over time and set its rate over distance to a 0.2. I don't know. Let's do 0.3. No, 4. Okay, I like it. Let me grab the Discus of Light game object and move it around to preview it. It's looking pretty good, but it's a bit too bright. So I will set its alpha to a lower value. Lower than that maybe. Okay, too low. Yeah, alright, now we're talking. Duplicate the bloom trail and name it line trail. Let's move it to the side real quick to work on it. Inside your materials, create yet another particle material called line trail material or whatever you want. Then assign the line trail texture you downloaded earlier. Drag the material to our particle system and move it around. It's looking alright, but the trail should not be stretching. So change the texture mode to tile. And now... okay, perfect. I'm going to make it a bit brighter though. Nice, alright. There's one more thing we have to do to these trails. In Elden Ring, they seem to move randomly within the Discus space. Ours don't, they just stay straight. To achieve this, we use a particle system force field. Drag it inside our Discus of Light and rename it force field, just to keep things short. Make sure its position and rotation are set to 0. Set its strength to 5. Select both bloom and line trail, then scroll to external forces and enable it. I'm going to move them around a little bit so you can see how they interact at the moment, and it's quite hectic. So set the multiplier to 0.1. Let's check it out now. Great, they no longer move on a straight line, and they kinda cross one another just like in Elden Ring. One quick thing I want to do is play around with the outer rings. I will increase its brightness and lower the rate over time and change the inner edge. That is actually much better. You could also make the trail particle system get smaller over time by enabling size over time and choosing a curve going down. But yeah, that is pretty much it for this tutorial. Go play around with it, change some values, make things fade in and out, increase or lower their emission rates, I don't know, go crazy. As always, all project files as well as these variations are available for my patrons to download and mess around with. I have a lot of cool content in there to help you in your game dev journey, so go check it out. Thank you all for watching, and I'll see you in the next video.